Hello everyone, welcome to yet another video of me going through the Form 4 textbook questions. So this is the video for chapter 2. So if you have not gone through my chapter 1 video and you think you would probably need help with it, please do check out the video in this channel. So without further ado, let's go into the content. So Form 4, Chapter 2 is number bases. So in this chapter, basically is all about expressing your different numbers in the different bases that we have. Okay, so before I go into the question, let's talk about how does all these base number work. So the basic numbers that we always use, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and so on, that is actually numbers in base 10. Okay, those are actually numbers in base 10. So your 1, 2, 3, 4, 5, 6, 7, 8, 9. After 9 is 10. So how does this work? Basically, each of the number is actually in one place value, what we call place value. So because it's base 10, once I reach 10, it's no longer anything in the first position. It no longer represents anything in the first position. That's why it's a 0 in the first position. It's a 1 in the next, in the next place value whenever I reach 10. Okay, so in other bases, it works the same way. But instead of reaching until 10, it reaches until whatever number your base is. So for example, if I have, say, base 8, let's just say base 8. So you go from 1, 2, 3, 4, 5, 6, 7. After 7, basically would be 8. But instead of writing 8, 8 is represented as a complete a complete number in that place value. So it carries over to the next position. It becomes a 1 and then a 0. And then 1, 1, 1, 2, 1, 3, 1, 4, all the way 1, 7. After 1, 7 will be 2, 0 instead of 1, 8. Because 8 is the base number. So once it reaches 8, I plus 1 in the next position. So same goes if I go until, say, 477. Okay, 477, let's say. So the next one will be 8. But reaches 8, I have to carry over. If I carry over the next one, this 7 becomes an 8 as well. So when it becomes 8, I carry over again. So after 477 is 500, then 501, 502, and so on. Okay, so whatever the base number is, once it reaches that base number, carry over the next position. Okay, that's how it works. So how that actually works is, for your base 10 numbers, back to base 10 again, for your normal numbers, let's say I have 3, 4, 5, 2, let's just say, in base 10. What it actually means is 3000 plus 400 plus 50 plus 2. So what would it mean in base number? It's basically 3 times of your 10 to the power of 3, 4 times of your 10 to the power of 2, 5 times of your 10 to the power of 1, and 2 times of your 10 to the power of 0. So the first place value is actually represented by your base number to the power of 0. Second position, base number to the power of 1, then to the power of 2, power of 3, and so on. So that's how it all works. Okay. Yeah. So let's look at some of the questions with this basics first. So first is completing the number sequence, means we need to know how to count up, okay, in your base, in whatever base number they give you. So like I said, once it reaches your base number, we carry over. So like here, after 2, 3, 4, after 4 is 5, but the base here is 5. So once it reaches 5, it carries over to the next position, becomes a 2, 4, 0, base 5. And then 2, 4, 1, 2, 4, 2. Yeah. That's how it works. This one, 1, 0, 1 in base 2. So after 1 is 2, so carry over to the next position. And this first place value here resets to 0. So it's 1, 1, 0 in base 2. And then 1, 1, 1. After 1, 1, 1, increase again, it will be 2. Carry over, it will also be 2. Carry over again, also 2. So it's the next position, 1. Then this 3 place value becomes 0. 1, 0, 0, 0, base 2. Yeah. This one is part C is very simple. 30 in base 7, after 30 is the 3, 1, 3, 2, then 3, 3. That's it, because it doesn't reach the base number, so no need to carry over anything. Yeah, just increase like normal numbers. Okay, that's the first question. Second question here, state the value of digit 2 in 3240 in base 4. So like I said just now, each of the place value is represented by a base number to the power of, first one is 0, second one power 1, third position power 2, fourth position is power 3. It keeps increasing the power starting from power 0. So the 2 here will basically be power 2, means it's 2 times of the base, which is base 4, to the power of 2. So it's 2 times of 4 to the power of 2, 2 times 16, 32. Okay, it actually represents 32. That's for question 2. Yeah. Now question 3. Convert 1110011110 in base 2 to base 8. And then this one convert to base 2. Now, converting bases, there are some special numbers that relates in special ways. This is one of the example. Okay, base 2, base 8, base 8, base 2. So base 2 and base 8 relates because 2 to the power of 3 is 8. That's why there's a special relation between base 2 and base 8. So same goes for base 2 and base 4, base 3 and base 9. Because base 2 and base 4, 2 to the power of 2 is 4. Base 3 and base 9, 3 to the power of 2 is 9. So there are special relations for these 3 sets of numbers. These 3 sets of numbers. Okay. All the other bases, if we want to convert, basically we convert to base 10, and then we convert to whatever place value that we want. Okay. So 2 to the power of 3 is 8. Basically, power 3 means 3 positions. So every 3 place value in base 2 is represented by 1 place value in base 8. Okay, because 8 means 8 to the power 1. 3 place value represented by the 1 place value. So how it relates? Basically, we just start with 0, 0, 0 in base 2 and a 0 in base 8. Yeah. So for base 8, we just keep increasing 1, 2, 3, 4, 5, 6, 7. There's no 8 in base 8. Once you reach 8, carry over. So it's a 1, 0. But we don't need that because we only want to represent one place value. So on the base 2, also I increase 1 by 1. So it's 0, 0, 1. After 0, 0, 1 is 0, 1, 0. After that is 0, 1, 1. And then 1, 0, 0. 1, 0, 1. 1, 1, 0. And 1, 1, 1. So each of these are equal. So by comparing them directly like this, I can change. So like I say, every 3 place value in base 2 is 1 in base 8. So I split 3 digits to convert base 2 to base 8. Split 3 here, 3 here, like this, 3, 3, 3. If, for example, if this is not a 1, if this 1 doesn't exist, then I put a 0 in front to make it a 3 digit. Yeah, you can always add zeros at the front of your numbers because it doesn't change anything. You cannot add it behind, that would change the number itself. But in front, we can always add a 0 so that it has enough digits if it doesn't have enough. Okay, so yeah, 1, 1, 1 in base 2 is basically a 7 in base 8. So for part A, first digit 7. 0, 0, 1 is 1 in base 8. So 1. 1, 1, 0. 1, 1, 0 is a 6 in base 8. So 6 base 8. So it's 7, 1, 6 in base 8. Yeah. For part B, convert 3, 6, 7 in base 8 to base 2. So I convert each of the number. 3 in base 8 is 0, 1, 1 in base 2. So if it starts with a 0, I don't need to write that 0. Can just start with the 1, 1. Yeah. Then 6 is 1, 1, 0. So 1, 1, 0. 7 is 1, 1, 1. So 1, 1, 1. Base 2. This is 7. This is 3, 6, 7 in base 2. Yeah, that's how we convert. So for base 2 to base 4, base 3 to base 9 is the same principle. How do we convert them? Basically, because it's power 2 and power 1, so it's 2 digits. Okay, every 2 digits in base 2 is 1 digit in base 4. So base 4, 0 to power 0 in base 4, 1 in base 4, 2, 3. It only goes up to 3. So 2 digits, 0, 0, 0, 1, 1, 0, then 1, 1. Yeah. Okay. So the 0, 1 I convert to a 1. Or from base 4 to base 2, then 1 I convert to 0, 1. Like that. Okay, same principle as this. But just that instead of 3 digits, it's 2 digits. So base 3 and base 9 as well. 9, 0, 1, 2, 3, 4, 5, 6, 7, 8. Yeah. So the base 3 also start with 0, 0. Then 0, 1, 0, 2, 1, 0, 1, 1, 1, 2, 2, 0, 2, 1, and 2, 2. Yeah. So for example, if I have 5, 7 in base 9, convert to base 3, then it will be 5 is 1, 2, then 7 is 2, 1. So 1221 base 3. Like that. Okay, that's how it works. So that is for the question 3 here. Yeah. Okay, and then all the rest of the conversion, we basically want to go through the base 10. We want to go through your base 10. So how does that work? Basically, I need to know how to convert any number to base 10 first. But let's not look at base 10 first. Before we convert to base 10, we have what we call the expanded notation. So what is expanded notation? It's basically this, what I did here. So when I separate every place value by itself, as an addition of every place value together, that is what we call the expanded notation. Okay, yeah. And how do we convert the base 10 from that? Basically, we add everything together. Yeah. So feel free to use a calculator to add them all together after you get the expanded notation. Okay, you don't need to count one by one. So how do we get the expanded notation? For example, let's say I have 4503. Yeah, let's just say 4503 in base 7. Yeah. So I know first position is power 0, power 1, power 2, power 3. Means the first one is represented by 4 times of 7, base 7, so 7 to the power of 3. Then plus the next one, 5 times of 7 to the power of 2. When it's 0, it's always the value of 0. Because 0 times anything is still 0. So 0, no matter where it still represents a 0, which is nothing. So there's no need to consider the place value where it's 0. Okay. So next one would be the power 0 position, which is the 3. Yeah. So whether you write 3 times 7 to the power 0 or you just write 3, it doesn't really matter. Yeah. Because anything to the power 0 is 1. Times 1, it doesn't change anything. So for last position, you can write the number itself. Don't have to write times your base number to the power 0. Okay, writing it out is not wrong, but there are times where they give you the expanded notation, and if you want to convert it back to numbers, you need to know that this is the same as times whatever base to the power 0. Yeah. So let's say from here, I want to convert to base 10. Okay. Then I just calculate 4 times 7 to the power of 3 plus 5 times 7 to the power of 2 plus 3. Then it will become 1620. Okay, in base 10. All right. So let's convert this to base 10 first. Okay, 287 in base 9. Okay, 287 in base 9, convert to base 10. So again, this is power 0, power 1, power 2. Yeah. Means 287 in base 9 is 2 times of 9 to the power of 2 plus 8 times of 9 to the power 1. So power 1, we can write 9 to the power 1, we can just write 9 as well. It's the same thing. Okay. Plus 7 times 9 to the power 0 basically it's just 7. So let's count this. 2 times 9 square plus 8 times 9 plus 7 is 241. Yeah, so it's 241 in base 10. Okay. Now, once we get base 10, we also need to know how to convert from base 10 to any base that we want. Converting it to any base that we want. So how do we convert a number from base 10 to whatever base that we want? Okay, so there are actually 2 ways of doing it. Okay, but I would strongly recommend the repeated division method or simple division. Yeah, you can call it repeated division, simple division. It basically the same thing. Okay. If you do not want to use that method, you can also use place value method. Okay. So let's do the repeated division method. I don't want to go through place value method here because it might waste a bit of time. So if you are interested to learn the place value method instead, you can always fast forward towards the end of the video, the end part of video. That is where I will do again using the place value method just to show you in case you are interested. Yeah. So let's do the repeated division method. So what we do is, so 241 in base 10, I want to convert to base 2. So what I do is, I start with 241. I divide by what base I want to convert it to, which is divide by 2. Okay, so if you just take 241 divided by 2, okay, it will be, if you want the exact value, is 120.5. But I don't want it in decimals. Okay, what I want is the whole number and then the remainder of it. Means I don't divide it completely unless there's no remainder. Okay, I divide and leave the remainder behind. Note out what remainder it is. So 241, if I divide 2, it will be 120 with the remainder of 1. Yeah. Okay, with the remainder of 1. Then I divide again. Divide by 2 is 60. That will not have any remainder. Divide by 2 again, 30. No remainder. Divide 2 again, 15. No remainder. Then I divide 2 again. It's 7. Now there's a remainder of 1. Divide 2 again, 3. Remainder of 1. Divide again, 1. Remainder 1. Don't stop at 1. Still divide 2 again. Divide 2 again is 0, but with a remainder of 1. Yeah. So I take the remainder from bottom to top. Okay, not from top to bottom, bottom to top. So it will be 1, 1, 1, 1, 0, 0, 0, 1 in base 2. That is part A, convert to base 2. Yeah. So the same method is used for all the bases here, from base 10 to any of this base. So let's say part B, try to convert it to base 5. Okay, so 241. Okay, start from base 10, not from the base 9. 241, convert to base 5 means I divide by 5. So 241 divided by 5 is 48, remainder of 1. Divide by 5 again. 9, remainder 3. Divide by 5 again. 1, remainder 4. Divide by 5. 0, remainder 1. Okay. Now, if you have trouble getting the remainder, or if you have trouble dividing, do not be afraid to use the calculator. So anyway, this one answer is 1431 in base 5. Yeah. Okay. So like I say, do not be afraid to use the calculator. So let's say if I take 241 divided by 5. So I only need to consider the whole number part for this. Okay. Then how do I get the remainder from this, you may ask? Look at the decimal part, 0.2. I take the decimal part times by whatever base you divided by. Times 5, I get 1. So remainder I know is 1. I take 48 divided by 5, 9.6. So the 0.6 I times 5, 3. Remainder 3. Yeah, that's how we can get remainder. If you don't want to put in decimal, if you want to put in mixed number, it's the same thing. Okay, 241. Or let's just take 48 divided 5. Put mixed number, shift SD to mixed number form. So the 3 over 5, 9 is what you get here. 3 over 5, I times by the base. Then I get the remainder. That's how it works. Okay. So you see, I can do the same thing for base 7 here. 2, 4, 1. Change to base 7 means divide 7. So maybe 7 is a bit hard to divide from 241. So use the calculator. 241 divided by 7. Yeah, let's say I put mixed number. If you want to put decimal, it's fine. Yeah, just that you have to get rid of the 34. So maybe you can like minus 34 and then times 7. Like that. So it's remainder of 3. Okay. Or you can just take mixed number form. Then I know 34 here. Then the 3 over 7, I times 7, which is 3. Remainder 3. Yeah. Okay. For smaller numbers, usually, personally, I prefer to count in the head. I feel it's faster. It's a lot faster. But don't worry if you need the help of calculator, just use it. Yeah. Don't be afraid to use calculator. Don't be shy to use calculator. Yeah. In fact, it's probably more useful to be familiar with calculator in this day and age. Yeah. It's just that if you use your mind more, it's like an exercise to your mind, which is good for health. Yeah, good for your mental health. Keep the mind active. Then when you grow old, less chances of Alzheimer's also. Right? So get back to this. I continue. 34 divided by 7 is 4. Remainder 6. 4 divided by 7, 0. Remainder 4. Yeah, always divide until you get 0. So remainder from bottom to top, 4, 6, 3 in base 7. So part D would be the same. Base 8, so 241 divide by 8, which is 30, remainder 1. Okay, 30 divided by 8 is 3, remainder 6. 3 divided by 8, 0, remainder 3. So it's 361 in base 8. So Like I say just now, is the fraction part times by the base number. Don't just take, you see like here, 3 over 7, the remainder is 3 because I times 7, it becomes 3. But not always it will be like that. For example, like this, if I take 30 divided 8, instead of over 8, it's over 4. So you don't just go and take the 3. It's 3 over 4 times 8, which is 6. Remainder 6. Okay, this is just in case you must misunderstand how it works. So that is for the question 4 here. All right, converting to from one base to another base without the special relations here. Okay. Now that you know how to do that, let's also learn how to calculate in different bases. Yeah. So how do we count in your different bases? The best way of doing it is by putting it in vertical addition and vertical subtraction. Don't worry about multiplication, division. They won't go and ask you. It's not even something I can do. Yeah. So addition and subtraction in the different bases. Put in the vertical addition or vertical subtraction form. In this case, addition. So 111 in base 2. Sorry, 111 in base 2 plus 1110 in base 2. So don't go and write 111 1110 like that. Doesn't make sense. It cannot be empty here. Base value must be correct. 1110 like this. Plus together. So 1 plus 0 is 1. 1 plus 1 is 2. So just like when you count up in your numbers, once you reach the base number, carry over to the next position. So 1 plus 1 is 2. So 0 here, I carry over 1 here. Okay. 111 is 3. So the 2 I have to carry over, but I still have an extra 1 here. So I leave that 1 here and carry over the other, the 2, the value of 2 in this position. Carry it over. Then 1 plus 1, again 2, carry over next position. So it's 1 here and a 0 here. Yeah. So basically it's 10101 in base 2. That's part A. Yeah. So it works in other bases as well, like this. 140 plus 302 in base 7. So same principle. Once you reach 7, carry over. If I don't reach 7, don't carry over. Nothing to carry over. Okay. So 0 plus 2 is just 2. 4 plus 0 is 4. 1 plus 3, 4. So it's just 4, 4 to base 7. Yeah. Let me just give you another example in case you don't understand any higher than base 2. If I have 2, 4, 5, let's say base 6 plus 1, 3, 4. Yeah, base 6. So 2, 4, 5, 1, 3, 4, base 6 plus together. 5 plus 4 is 9. So out of 9, I only take the 6 to carry over. So I have an extra 3 that's left behind. Yeah. The 6 that carry over becomes a 1 here. Okay, don't go and put 6 here. Carries over becomes a 1. Yeah, it's like reaching 10. Once you reach 10, bring the 1 over. Okay, you don't go and make it into another number. So 1 plus 4 plus 3, 8. Again, 8 more than 6. So the 6 I bring over, the extra 2 remains behind. Okay, like 8 is basically 2 plus 6. So the 2 carry over becomes the 1 here. The extra 2 remains in that position. Okay. So 1 plus 2 plus 1 is 4. So means this becomes 4, 2, 3 in base 6. That's how it works. Okay. Now, part C here is a subtraction question. So subtraction, what we do is also put in vertical subtraction. Now, if I subtract and I cannot subtract from with the number below, basically what I do is I take 1 from the next position, from the next base value, take 1 out of it, left with 6. Yeah. So if I take 1 from here, 1 here represents a 9 because your base here is 9. Yeah. So it means the 5 I plus 9 becomes a 14. Then I minus 14 minus 8, 6. 6 minus 1, 5. 2 minus 2 is 0. 0 don't need to write. So it's 5, 6 base time. Okay, it's just like if I take, say, your normal numbers 2, 5, 3 minus 1, 3, 7, let's say. So 3 I cannot minus 7, that's why I take 1 from here, it becomes 13. Then 13 I can minus 7. So then 106 is the same principle as that. Just that it's not a 10, it's whatever your base number is. I plus to it. All right, that is calculations in the your respective bases, whatever base that you want, they want you to calculate in. Okay. Question 6 here. If you want to determine whether each of this is true or false, basically the best way to determine is we put it both to the same base. Okay. Now, usually what I would do is I would change it all to base 10. Yeah, because I don't need to know it in base 8, I don't need to know it in base 4. But if both in base 10, then I already have the value. And converting to base 10, for me, I would think is more simple than converting from base 10 to the respective bases. That's why I would generally choose to convert to base 10 for both numbers. But if you want to convert, say, the base 4 to base 8 or this base 8 to base 4, you can as well. Okay, it's up to you. Yeah, it's up to you. You have the power to make that decision. Okay, but like I say, I prefer to just change it all to base 10. So that's what I will do here. Then I know whether it's true or false. 1, 2, 3 in base 4. Power 0, power 1, power 2 means it's. So what I will do is, personally, I will straight away type into the calculator. Because it's not going to give you marks for working. So I choose not to write out the working. Yeah. So 1 times of 4 to the power of 2. So I put 4 square plus 2 times base 4 power 1 means it's just 4 plus 3. So this is 2, 7 in base 10. The other one, 2, 3 in base 8. So power 0, power 1 means is 2 times of 8 to the power 1 plus 3. 1, 9 in base 10. So compare these two, this is bigger than this. Yeah, so the inequality sign, same direction, which basically means is true. Yeah. Okay, 7 2 in base 9. So again, power 0, power 1. 7 times 9 to the power 1 plus 2, 6, 5 in base 10. 3 4 1. 3 times of 5 to the power of 2 plus 4 times of 5 plus 1, 9, 6 in base 10, which is also this way, also true. And the final one, 4 5 2. So 4 times 6 to the power of 2 plus 5 times 6 plus 2. 176 in base 10. Yeah. The other one, 3 times 8 to the power of 2 plus 3 times 8 plus 4. 220 in base 10. So we compare this in base 10, obviously 220 is the bigger one. Wrong direction. So this is false. Yeah. Right? It's true, true, false. That's for question 6 here. Comparing between the numbers in different bases. Convert both to base 10 or convert one of the number to the other base, like base 9 to base 5 or base 5 to base 9. Then compare. Okay, it has to be the same base, then only we can clearly compare them. Yeah, if not, it's a bit difficult to actually just see what base it is. What the value, how the value compares with one another. All right, that's the question 6 here. Question 7 here. 110 in base 2 plus 278 in base 9 plus 132 in base 4. I want the value in base 10. Since I want the value in base 10, change everything to base 10 and count. That's the best way of calculating it. Right? So generally, I won't put it all together and count straight away. For this kind of question, it's best to separately convert each of it to base 10 first. Yeah, if not, it will be very, very long and messy to see. So whenever we want to check back, also it will be a bit difficult. Okay. Yeah. And also, let me just teach you another thing, which is calculator has base 2, base 8, and base 10. Okay. It also has what we call base 16, which is called the hexadecimal. So you see this, DEC means decimal. Decimal is your base 10. HEX is hexadecimal, which is base 16, but don't worry about that. You will never use it in your syllabus. Yeah, even if you go A levels, you will not be using that. Hexadecimal, if you're maybe at a level of programming, you can use it. Yeah, but generally for laymen, for normal people, you wouldn't be using it. Personally, I do not use it as well. So BIN is binary, which is your base 2. So binary numbers is the most basic number in your programming language actually. Okay, so if you watch Matrix, you will see 0, 1s, you will see like, yeah, a whole screen of zeros and ones, or any other, say, programming show. Yeah, you might see it, or some hacker show, you might see it, zeros and ones. So the zeros and ones is actually your base 2 numbers. And base 2 numbers is the basic of how your computer programming all came about. Okay, everything circuit actually operates based on principles of 0 and 1, on and off, yes, no. Yeah. Okay. So yeah, that's binary. OCT is octal. It's like octopus, base 8 tentacles. Yeah, so 8 is octal. So that's why octal numbers is base 8 numbers. So if I want to convert, basically press mode until you see base. Okay, if you're using 350 ms, just press a few more times, you will see base. Select that. Then to change between the different base, basically you just press this 4 button. Don't need to press shift alpha or anything, just press that to change. So if I want to change from base 2, means I start in binary, 110 equal, change to base 10, press decimal. So it's 6. So basically this is a 6 in base 10. Right? Convert this to base 9. Sorry, convert base 9 to base 10. We cannot use calculator because there's only base 8, base 2, base 10, base 16. So all the others, I still need to use the manual method. Okay. Yeah. If you need to go back, you can clear. Okay. Or let's say from base, I can just press mode 1. Yeah, that's the default one. So 278 in base 9 means two times of, so power 0, power 1, power 2, 2 times of 9 to power 2 plus 7 times of 9 plus 8. Then I just count. 2 times 9 to the power of 2 plus 7 times 9 plus 8. 233 in base 10. So this is 233 and 134 in base 10. Same thing. Convert 1 times of 4 to the power 2. You can write 1 times 4 to the power 2. You can just write 4 to the power 2, so it doesn't really matter because times 1 is the same thing. 3 times of 4 to the power 1, which is just 3 times 4. Okay, wait, sorry. My bad. This is a 2. So 2 times of 4 to the power 0 means it's 2. 4 squared plus 3 times 4 plus 2. 30 in base 10. Yeah, so this is this. Add them together. 6 plus 233 plus 30. 269 in base 10. No need to use manual calculation. Base 10, just plus using your calculator is fine. Right? So that's for question 7. Question 8. Same thing. Basically the same thing, but subtract. So basically do it the same way. All right. 231 in base 4 is 2 times 4 to the power of 2 plus 3 times 4 plus 1. Which is 45 in base 10. 110, basically in the previous question, I already did, which is 6. So means this is 45 in base 10 minus 6 in base 10, 39 in base 10. Yeah, that's it. Very, very simple question after we already done question 7, because it's basically the same principle, and one of it I even already converted before. Okay, that's question 8 here. Now, question 9 here. 1122 in base 3 plus y in base 7 is 118 in base 9. I want to count the value of y, right? So y here is in base 7. Basically, I need to convert to base 7. So before that, let's rearrange this equation. Okay, just like your normal calculation, I can get rid of this plus opposite minus. So I minus the 1122 in base 3. Left with the y in base 7. So this side also minus 1122 in base 3. Yeah. So basically I need to minus this. This you can convert, calculate in base 9 or calculate in base 3. Then only you convert to base 10, then base 7. Or convert to base 7, count, then convert to base, convert to base 10, count, then convert to base 7. That would also work. Okay. And I think personally for me, I would just convert to base 10. Yeah. So 118 in base 9, convert to base 10 means 9 to the power of 2 plus 9 to the power of 1 plus 8. 9 squared plus 9 plus 8. 98 in base 10. 1122 in base 3. 1 times of power 0, power 1, power 2, power 3. So 1 times of 3 cube plus 1 3 square plus 2 times of 3 to the power 1 plus 2. 2 times of 3 to the power 0, which is 2. 3 cube plus 3 square plus 2 times 3 plus 2. 4 in base 10. So this is basically 98 in base 10 minus 4 in base 10, which is 54 in base 10. Then I convert to base 7. Okay, so from base 10 to base 7, again, repeated division, divide by 7. Divide by 7 is 7, remainder 5. Divide by 7 again, 1, no remainder. Divide by 7, 0, remainder 1. So remainder from bottom to top, 105 in base 7. So y is 105. Yeah, that's for the question 9 here. All right. Then let's continue here. Question 10. Fill in the blanks with numbers in ascending order according to the given bases. Yeah. Okay. So if you see here logically, 6 3 here, 6 7 here in base 8. So means it's probably 6 3, 6 4, 6 5, 6 6, 6 7. If I put all in base 8. Okay, so this logically would be 6 3, 6 4, and then here 6 5. Yeah. Same principle works on base 2. 1 1 0 1 0 0 means 1 1 0 1 0 1 is the next. Then the one after would be 1 1 0 1 1 0. Yeah, after this is this. Okay. Part B, now it's just like decreasing bases. Okay, but basically it should work the same way as well. since I have base 10, after 1 to 4, it's either 1 to 5 or 1 to 6. Okay. Sorry, it's either 1 to 5 or you will decrease to 1 to 3. Okay, wait, sorry. No, it's all ascending order, my bad. Yeah, so let's just check whether it's increasing in this 1 by 1 or not. Okay, that's just to double check lah. Okay, so if I convert from base 10 to base 9, after 1 to 4 is 1 to 5. I convert to base 9. So divided by 9 is 13, remainder 8, 1, remainder 4, 0, remainder 1, so 148. Yeah, so it should be working in the same principle. So means next one, here 1 to 4, base 10. So it's 1 to 5 in base 10, 1 to 6 in base 10, 1 to 7 in base 10, and 1 to 8 in base 10. So just convert from 1 to 6 to base 8, 1 to 8 to the base 5. All right. So 1 to 6 to base 8, divide by 8, 1, 5, remainder 6, divide by 8, 1, remainder 7, divide by 8, 0, remainder 1. So it's 176. If you're not sure, you see, you can also use calculator, decimal, 126, binary, octal, 176. You can see it's the same value, right? So base 5 here, also same thing. 1 to 8, convert to base 5, 25, remainder 3, divided by 5 is 5, no remainder, divided by 5 again, 1, no remainder, divided by 5 again, 0, remainder 1. So from bottom to top, 1, 0, 0, 3 in base 5. Yeah, that's for the question 10 here. Okay, then question 11 here. Total number of visitors to Zoo Nagara in January is 20202 in base 5. What's the average number of visitors to Zoo Nagara each day in January if it opens every day? Yeah. So January has how many days? January has 31 days. Okay, so I want the average number of visitors every day in January. So I need to basically divide by 3. Yeah, divide by 3. But can I divide by 3 just like that? Yeah, I think that would be a bit difficult. So rather than just dividing by 3, let's convert the base 10, divide by 3, then convert back to base 5. Yeah. So when we do normal calculations, use your base 10. Yeah. Because that's how we understand it on a day-to-day basis. So, yeah. So no need to try to complicate things, think of a special way to instantly straight away calculate your base 5. You can always convert it between your bases, yeah, because you have already learned how to convert between any base to another base. So best is use the base 10 number that you are definitely very familiar with, yeah, by now in your form 4. So convert to base 10 first. So see here, power 0, power 1, power 2, power 3, power 4. Means I take 2 times of 5 to the power 4 plus 0, I can just ignore. So here 2 times again, base 5, power 2. 0 again, skip. 2 times of 5 to the power 0, basically is 2. So I count 2 times 5 to the power 4 plus 2 times 5 square plus 2. 1302. Okay. In base 10. Total is 1302. Means average would be 1302 divided by 3. Sorry, divided by 30, which is, yeah, because it's, sorry, my mistake, 30. January has 31 days, divided by 31. So 1302 divided 31, 42. This is in base 10. Change it back to base 5. So in base 5, convert, divide by 5, 8, remainder of 2, divide by 5, 1, remainder 3, divide by 5, 0, remainder 1. So from bottom to top, 132 in base 5. That's the question 11 here. All right. Now, question 12. Azizan buys a bag filled with 100 small balls for his son, and 1/5 of the balls are green, 1/4 are yellow, 1/8 are pink, and the remainder is blue. So they want number of blue balls in base 8. Now, this one, there's a quick way of doing it, which is, you remember from before, you should already know this principle, which is total fraction of everything together is always equal to 1. Yeah. Total fraction, always 1. Just like your total percentage. Total percentage of everything together is always 100%. So it's the same principle with your fractions. Total fraction is 1. So if I want to count fraction that is blue, okay, fraction of it that is blue, I take 1 minus all the other fractions. Minus 1/5, minus 1/4, minus 1/10. Nine over 20. Yeah. Okay. So number of blue balls will be 9/20 of the total number of balls, which is 100. It's given in the question here. So 9/20 times 100, which is 45. So there are 45 blue balls, but this is in base 10. What they want in the question is in base 8. So we just convert. 45 convert to base 8. 45 divided by 8. 5 remainder 5. Divide by 8. 0 remainder 5. So 5 in base 8. Yeah. Or if you don't want to convert manually, you can use your calculator to do so as well. See, decimal 45, octal 55. Yeah. right? Then question 13. Kishendran buys a batik shirt at a discount of 25%. Original price of the shirt is 220 ringgit, but base 4. Yeah, in base 4. So what is the price of the shirt after discount in base 7? So same thing. Don't need to do unnecessary calculations in other bases. Okay, unless it's like base 4, you want plus or minus. Same base, you plus minus, then you can keep it in that base. If not, put it in base 10. Yeah. 220 in base 4. Convert to base 10. 2 times 4 square plus 2 times 4. Yeah. 2 times 4 square plus 2 times 4, 40. That's in base 10. Okay. So this is the original price. Means original price is 40 ringgit. Discount of 25% means price after discount. Price after discount would be 75% of the 40 ringgit. Yeah. Okay, because discount 25% means 25% don't need to pay. Means you have to pay the remaining 75%. So 75% of 40 ringgit is basically 30 ringgit, but this is base 10. What I want is base 7. So convert 30, change to base 7. 4, remainder 2. Divide 7, 0, remainder 4. 4, 2 in base 7. Yeah. That is for the question 13 here. Yeah. So basically, that is all you need to know for chapter 2, number bases. Okay, the main thing is converting between your different bases. Once you get that done, the rest shouldn't be much of an issue. All right. So as usual, I'm from Pusa Tuition 30D. So this is we have books, notes and tutorials, topical practice, drill practice books that you can buy. If you wish to purchase, you can contact us. Yeah, we also have a Shopee shop that you may want to visit if you want to get our materials and all. But if there's any other queries, don't hesitate to call us, message us, whether it's through WhatsApp or through our social media. Okay, do follow us on our YouTube, Facebook, and Instagram if you think we are of any help to you. So that's it for this video. I'm Damian. Thank you for watching. I'll see you in the next one.